Okay, so this is a little review video on factoring polynomials and the way that I like to do it. So we'll go over the basic steps, the things that you should think through, and then we're going to go through mainly how to factor trinomials in this process. So the very first thing, anytime you factor polynomials, the very first thing you should do is factor out the greatest common factor. So that's a step that a lot of times people forget, and then they end up with making the problem more complicated. So your mind just needs to immediately say, I'm factoring, so first thing, GCF, okay? Then the next thing you're going to look at is what kind of polynomial do you have? So you can have two terms in your polynomial, and if you have two terms, there's really two cases of anything that you would be able to factor, and one would be a difference of squares, and this is the one you definitely need to know how to do. This one comes up quite often, and it would be when you're looking at something that is a squared minus b squared. So a and b might be variables, they might be numbers, they might be functions. It's anything squared minus another thing squared. As long as it fits that format, then it can be factored as a plus b times a minus b, and it doesn't matter if it's a plus b, a minus b, or you write a minus b, a plus b, of course, because it's multiplication. So whatever you're squaring in each case, you multiply plus and minus of those two things. So that one you should be very familiar with. The other one is the sum or the difference of two squares, or cubes, sorry. This one really doesn't come up enough for us to spend a lot of time memorizing it. You need to be aware that there's a formula for it, and if you can remember it, great, but it's not going to come up enough to probably spend a great deal of time memorizing, and that's when you have a cubed, and it can either be plus or minus b cubed. So the two signs there are just saying if it's plus, you're going to follow the top sign on this whole formula here, and if it's minus, you'll follow the bottom. So it's going to be a, and then it's the same sign here. So it's going to be a plus b if you were doing a cubed plus b cubed, and it's going to be a minus b if it was a cubed minus. And then it'll be a squared, and then this sign will be the opposite. So this will be minus if the original problem was the sum of cubes, and plus if it's difference. The middle is ab, and the last sign is always plus. So again, mostly be aware that formula is there. Those of you good at memorizing formulas, then go for it and memorize it. But otherwise, we don't use it often enough to waste our brain space on that. We have a lot of things to remember. All right, so number 3 is the main one we're going to spend time with, and that's if you have 3 terms. And in those 3 terms, you have a quadratic type equation or expression. So it doesn't have to be a quadratic, but it needs to be like one. Today we'll just do quadratics, but you need this for future. So it's a times something squared plus b times the something plus c. More commonly for us, it's ax squared plus bx plus c. And that's the a, b, and c that we will refer to most in this video. This is primarily what this video is over, is factoring quadratics. So you will be looking for factors of a times c whose sum is b. And then there's a whole procedure for what you do with those numbers after you find it, and that's what this video is primarily about. So I can't put a shorthand on that. You're going to just have to go through the method and learn it. But the numbers that we need are based on that, and it's because it has to do with foiling, and that's how we're going to explain it today. The last step in factoring is if you have 4 terms or more, And basically what you would try to do, and this is always after you've already done the greatest common factor if there is one, and then if you have 4 or more terms, you're going to try factoring by grouping. And then either that will work or it won't. And then if it doesn't work, it can't be factored if you've tried every possibility, which is not always that easy if you have 5 or 6 terms, but that's the next thing we would try. So again, today's focus is primarily here on what to do when we have a quadratic or a quadratic type equation. All right, so we're going to do quite a few examples. Feel free to hit pause at any time if you need to write the problem down or catch up or think about it for a minute. That's the reason that a video is very helpful. So the instructions on every example today are factor completely, which means I can't have anything left in the factors that they have in common. So first example, we're going to do x squared plus x minus 42. So we're going to do some of these in what you might consider a long way because you may know how to factor them a different way, but you need to go ahead and follow and do all of this because it will lead us into a way that we can do all of this factoring quicker, but we need an understanding. And the understanding comes from doing it this a little bit longer way for a little while, and then it'll make more sense how we can do it a shorter way. So in this problem, I recognize the first thing I look for is there a greatest common factor, and there's clearly not. So then I look to see that it's a trinomial, so it's a quadratic type equation. So I would be looking for factors of a, which is 1, times c, which is negative 42, whose sum is b, which is 1 again. So don't forget that there are 1s right here. We just don't usually write them. So over to the side, I'm going to write negative 42 because that's the product a times c. Then I'm going to write down all the factors of negative 42 until I find a pair that adds to 1. Now, if you later, after you've learned the methods, if you figure out the answer right away, then you just write down what you need and then move on. But right now I want to be sure we know how to find it even if the number was 342 or 480 or something that has a lot of factors and we don't want to just sit and guess all day. So the first factor you should always write is 1 times the number, so 1 times 42. Now, 1 times 42 does not equal negative 42. One of these two numbers has to be negative. The thing that I need to remember is what I'm looking for is a sum of those two numbers that ends up being positive 1, which means that it has to be the smaller number that would be negative if I'm going to add two things, a negative and positive, and get positive. So I'm just going to write all my factors down and then just stick a negative sign with the smallest number. Now when I list my factors, I go in order. So I start with 1 times 42. Then I'm going to do 2 times 21, and I'm going to put the negative with the small number. Then I'm going to try 3, so that's negative 3 times 14. If you need help, you can't figure it out, just go over to the side and do a little scratch area for division. Do not use a calculator. We need to know how to use our brains. It only took that little bit of time to figure out the answer. It's not that difficult. 4 doesn't divide into there. 5 doesn't divide into there. 6 does. It's 6 times 7. And then, of course, I'm putting the negative on the small ones. Now, I know that I'm finished and I have every pair of factors for negative 42. Because if I were to keep going, the next number I would try is 7, but 7's over here on the right, so that means I've actually exhausted everything. So I'm starting to repeat, so I'm done. Well, clearly, negative 6 plus 7 is going to be my positive 1. So we're going to go, again, the long way here. So we're going to do what's called factoring by grouping. So I'm going to take those two numbers that I just found, negative 6 and 7, and I'm going to rewrite the 1x by writing it negative 6x plus 7x. So all I did was take this and rewrite it like that. Now what I'm going to do is what we call factor by grouping. So I'm going to group these. I'm going to group these two together, and I'm going to group these two together. Now you can circle very lightly with pencil. I can't really circle lightly here, but always leave this plus sign right here in the middle, don't circle it in anything because you're separating it into two groups of 2. Now what we're going to do is factor each of those two things. So in my first little group of 2, what I have in common, because the first thing I do in factoring is GCF, I have an x in common. So I take out the x, and I'll be left with x minus 6. You always bring down that sign, whether it's addition or subtraction, you carry it down, and then you factor out what we have in common in the last 2 terms. Well, I have a 7 in common. If I factor out a 7, I get x minus 6. Make sure you're always distributing back to verify that it is in fact correct. Now, this is the part that a lot of people get confused about, but it's vital to this method. And then in a minute, we'll see why I did grouping to understand this, the other thing I'm going to teach you. We've now made 2 terms. That's a term, and that's a term. That's 2 terms now, separated by that plus sign. So now what I'm going to do is look for what do those 2 terms have in common. Well, they each have a factor of x minus 6. So I pull out x minus 6, put my parentheses, just like I did up here with the x. Okay, put my parentheses, so then I look. If I take out x minus 6, then I'm left with x on that term, plus, if I take out x minus 6, I'm left with 7. And now I'm done. Now again, I realize this is kind of a long way for this particular problem because a is 1, but you're going to see why it makes sense after we do a couple more. So what I want to do here is I want to FOIL this and see what it has to do with this line right here, because that's the secret to the quicker method that we're going to do. So if I do my FOIL and I do my first, I get x times x, which is x squared, and that's the first term I have up here. I have x squared. Then I do outside, I get 7x. Well, here's 7x up here. Inside, I get negative 6x, and here's that term right there. And then last would be these 2 products, and that would be my minus 42. So all I'm essentially doing is I'm doing FOIL in reverse. So I'm finding the 2 things that make up the outside and inside. And that's really important to understanding where we're going. All right, so we're going to do one more like that, and then we'll move on to where a is not 1. So we have r to the 4th plus 11r cubed plus 30r squared. Doesn't have to be x, it can be anything. So we're going to go through the process with this problem. So very first thing I need to do is look for a greatest common factor. So this one definitely has a greatest common factor, and that's r squared. So I need to pull out r squared from all of these terms and write what's left. So I think to myself, r squared times what is going to leave me r to the 4th. That would be r squared, plus r squared times what gives me 11r cubed. So that would be 11r, plus r squared times what, and that would be 30. And so that's a way that you can think about when you factor something out. So now I'm going to go through the same process that I just went through, but I'm going to go with the little bit faster method because a, which is actually right here, is 1 here. So I'm going to go through a little quicker, then I'll show you how to do it when a is not 1. We'll go through grouping, and then I'll show you the quick way. So I need factors of a times c, and that's going to be 30, whose sum is 11. So again, write all the factors down, get in the habit of practicing that, because as soon as it's 300, you're not going to be able just to guess around when it's not factors that you're thinking of. So just write them all down. 1 times 30, 2 times 15, 3 times 10, 4 doesn't work, 5 times 6, and then again, I know I'm finished. I've written every factor, and those are the ones that happen to add up and are correct. So when a is 1, you notice on this last example that our outside and inside products were the 2 numbers that I found over there, and they ended up being these 2 numbers right here. So only when a is 1 you can simply write in r plus or minus, whichever, if positive or negative, each of those numbers. And that's because your outside product and your inside product are going to add together, and they're going to each get multiplied by 1. And so it's easy to fill in. So when A is 1, you just have to fill them in. Now, most of the time, that's not our issue. The problem we have is when A is not 1. So let's look at an example of that. So we have 2x squared minus 3x plus 1. So we're going to do this by grouping first, and then I'll show you how you could fill it in quicker, and then all the rest of the examples today will all be the shorter version, and I'll explain it to you as we go to give you plenty of examples. So first thing I look for is, does this have a greatest common factor? And that does not. So then I look for factors of A times C, which would be 2 times 1. So factors of 2 that add to negative 3. Now you might look at that and go, well, that's ridiculous because 2 only has factors of 1 and 2, and 1 plus 2 is not negative 3. Well, remember that if you have a positive number, then you either take a positive times a positive or a negative times a negative. So you could also have negative 1 times negative 2, which now definitely does add to be negative 3. So don't forget that if the factor, the product you found is positive, the factors are both the same sign. So either both positive or both negative. Since my sum needed to be negative, then I'm looking at the negatives. So we're going to rewrite the middle again by rewriting negative 3x as minus x minus 2x. So all I did was rewrite the middle. Now I'm going to very lightly, in your case, just very lightly sort of circle these. Again, do not get that negative sign in this circle. You're just circling the two terms. And now we're going to factor by grouping. So what do we have in common in the first circle? Well, we have x. So that's going to leave us 2x minus 1. And then we always bring down this term. Now, here's one that's a very good example to show you several things. So we look and we say, okay, so what do those two terms have in common? Well, you might say, well, they have nothing in common. But remember, everything has a 1 in common. And in this case, I would write that, even though it seems like something we don't need to write. If you'll write it here, you won't be so confused. So basically, you take out what they have in common, which was a 1. But actually, what we took out was negative 1. And we need to keep that in mind. So now think to yourself, negative 1 times what is going to give me negative 2x, because that's what I have above. So this would be positive 2x. Then I think to myself, negative 1 times what is going to give me positive 1? Well, this would also have to be negative 1. Now, you'll notice that I ended up with the same thing inside the parentheses. If I'm doing factoring by grouping correctly, I should always end up with the same thing in the parentheses. If I don't end up with the same thing, then I've either picked the wrong factors, I've made a mistake, or something has happened there. So you need to always check by foiling and you'll catch that. So now I look and I see that we have this term and this term, and I want to take out what they have in common. Well, what they have in common is the factor 2x minus 1. Then I'm going to write down what's left. Well, if I take out the 2x minus 1 from the first term, I'm left with x, minus, if I take out 2x minus 1 in the second term, I'm left with a 1. And that's the part that makes it the reason I want to write the 1 there when that was all they had in common. Otherwise, you kind of get confused about, well, there's nothing there, so they don't have anything in common. All right, so now let's look at FOIL so that we can see how that matches up. So if we go through FOIL again, we'll see that 2x times x is my 2x squared. So that's always going to end up exactly just whatever the first term is. My outside is a 2x times a negative 1. That's this one. Inside is negative 1 times x. That's that one. And last is always the product of these last two things, and there it is, plus 1. So the way we could have filled this in from the beginning is I would have just found these factors over here on the right, and I would have written my sets of parentheses. I know it's going to be a binomial times a binomial. Well, I know that the first term is 2x squared. And if I'm factoring, it means I'm only using integers. If I'm only using integers, the only way I can get 2x squared is 2x times x. And so I go ahead and fill that in. That's how it's going to start, 2x times x. Then what we just learned is that this product out here and this product in here, ignore the x's, I'm talking about the constants, the numbers. Those two products have to be these two numbers. And so all I have to do is fill in what makes that work. So on the first one, I have 2 times something has to equal one of those two numbers. Well, 2 does not divide into -1. 2 times an integer is not going to be -1. So I must be making the -2 on this outside product here. So 2 times what is -2? That would be -1. Then my inside product here, remember that there's a 1 here. We don't put it there, but there is 1. 1 times something is going to be the other number, which is -1. Well, 1 times -1 is -1, and I'm done. And I got the same answer. I did not have to do all the grouping, and I just kind of filled it in. So all the rest of the examples today, I will find all the factors, and I'll show you how to just fill it in. But it's not guessing. It's actually solving it and doing it. I do not like trial and error or guess and check or any of those types of things. You need to actually know how to do the work, because when you have numbers that have 25 sets of factors, you're never going to, just guessing and checking is not a good method, okay? So we don't have to do that. We can figure it out. So here's our next problem. Oh, and I mixed, the page had R's on it, and I decided to change it to X's. Easier for me to draw X's. So 4x squared plus 39x minus 10. So here's your process. First step, do I have a GCF? And the answer is no. Next step is it's a quadratic. So I'm going to factor it by looking for factors of a times c, which is 4 times -10. So that's -40. And I need the sum of those factors to be positive 39. So first thing I'm going to write is 1 times 40. Now, I know one of those has to be negative, but when I add the negative and positive two factors, I'm supposed to get positive, which means the negatives would have to be the little ones. And then guess what? This time I don't have to do anything else because those are the right factors. That adds to 39. So I don't have to write anymore. So worst case scenario, I have to write all the factors down, but at least I find my answer. Great if I just figure it out right from the beginning. Okay, so I'm going to go immediately to 2 binomials. Now, here's the difference in this problem. This time, your first term is 4x squared. So I have to make these two first parts equal 4x squared. Well, this time there's 2 different possibilities. It could be 4x times x, or it could be 2x times 2x. But what I have to remember is I have to use those two numbers, 4 and 1, or 2 and 2, to make these two factors over here. Well, if I used 2 and 2, I can't take 2 times an integer and end up with -1. So 2 and 2 is not going to work. It's going to be 4 and 1. So I do 4x and x. Now, this product out here and this product in here, again, not the x's, the numbers, have to equal. One of them is going to be -1 and one of them is going to be 40. Well, obviously the 4 is going to be part of making a 40. So 4 times 10 is going to make 40, which leaves this other one. Remember, there's a 1 here. 1 times what gives me the other number, which is -1. So that's 1 times -1. And I'm finished. And we can check it really quick. You should always do that. Immediately check every factoring problem. So I simply just do FOIL real fast. 4x times x is 4x squared. 4x times 10 is 40. X, 1x times a -1 is -1x. So you have 40x minus 1x. There's your 39x. And then your last term is negative 1 times 10, negative 10. And I'm done. So it will get easier. The more you do, the more you'll start to see exactly what's going to happen. So let's go ahead and do the next example. So on this one, we have 3x squared minus 16x minus 35. So first step is look for a greatest common factor. I do not have one here. So now I need to find factors of a times c whose sum is b. Well, a times c is 35 times 3. Do not grab a calculator. Just go over here to the side if you can't do 35 times 3 in your head and write it down. Then don't forget it was a positive times a negative. So it's a negative 105, and I want the sum to be negative 16. So again, just start writing them down. The first one you should always write is 1 times whatever. And then remember, it's a negative 105. So one of these two factors has to be negative. Ultimately, I'm going to add them together, and I want negative 16 for the answer. So that means it must be the bigger number that has to be negative. Now, obviously, this one doesn't work, so I just need to keep trying. So the next one would be trying 2, and obviously no even numbers are going to work here, so I go to 3. 3 does work, obviously, because I just made it 3 times 35. And then remember, I'm putting negative on the big one. So 3 times negative 35 does not add to negative 16. I don't need to try 4 because no evens are going to work, so we'll try 5, which we know works. 5 will go into 10 twice, and then 5 goes into 5 once. And then we know the negative is on the 21. And there we have it. 5 times negative 21 is negative 105. 5 plus negative 21 is negative 16. So I found my answer. So I go down here, and I'm just going to immediately fill in my two binomials. So first is 3x squared. Well, this time there's only one option. 3x times x. That's the only way I'm going to get 3x squared. And then I want my outside product and my inside products to be those two numbers over here that I found. Well, 3 does not divide into 5, so this outside product must be to make the negative 21. So 3 times negative 7 gives me negative 21. And then on the inside, I have a 1 already, so I need 1 times 5 to give me a 5, and I'm finished. Factored, done, quick, no guessing, and there we go. Check it by FOIL really fast. I'm not going to check every one of these, but you should check them by FOIL to help get the method down. All right, number 6, example. We're going to do just a couple more here. So 45x squared minus 70x plus 25. So here's a really good example of where you need to be careful to notice that you need to take out the greatest common factor. Otherwise, you're over there to the side trying to do 45 times 25 and then find all the factors of it until you get some that add to negative 70. Well, I need to recognize the fact that they certainly all have a factor of 5. So take out a 5 from each one of them, and that will make life easier. If you don't know how to do 70 divided by 5, again, you can kind of do it to the side, or just, think 5 into 7 goes once, and you'll have a 2 left over. That leaves a 20, and you get that. And then if you can't figure it out again, just go over to the side. Do not use a calculator. Got to make our brains work. So now the new problem is we're just going to tag on the 5 over here on the side. It's just going to stay multiplied by this answer. So I'm looking at the inside only. I'm just looking at this trinomial to factor. So I need factors of 45, that's 9 times 5, that add to negative 14. So the first one I'm going to write is 1 times 45. But again, I'm never going to add two positives and get a negative 14. So that means both of these are negative in this case. Again, no evens are going to work, so I'm going to go to 3. 3 goes in there 15 times, but negative 3 plus negative 15 does not work. And then I get negative 5 times negative 9, which does work. That adds to negative 14. Now, if you just figured that those two factors out immediately, that's fine. Just write those two numbers down and move on. But if you can't figure it out, don't sit and guess all day and stare in the air. Make a list, make it systematically until you find the answer. Okay, so now we have another one where we have to think just for a second how to get started. It's 9x squared for the two first terms. So it could be 9x times x, or it could be 3x times 3x. But if I were to do 3x times 3x, 3 does not divide into negative 5. So I'm not going to be able to make that factor. So it must be 9x and x. And then I do the same process. Outside product is one of those numbers. So I must be making the negative 9. So 9 times negative 1. Inside product is 1 times something to equal negative 5. So of course that'll be negative 5. And that's it. So again, FOIL to go through it and make sure that you're following and understanding everything. Okay, so let's go to, and I think this will be the last example. We're going to just do this one more example. And I think that'll be enough. You can always look back at some other ones, ask questions in class, things like that. Okay, so we have 8b squared minus 31b minus 45. So the first thing we need to do is look, do we have a greatest common factor? Well, unfortunately, 31's prime, so I'm stuck here. I have no greatest common factor. So I am going to have to go for this bigger product. So 45 times 8, I'm just going to go over here to the side and do that product. So I'm going to get 360, and it's negative. Now here's a perfect example of something that has a lot of factors, and randomly guessing is probably not going to land you on the answer very quickly. So we want to have a method, okay? So first I'm going to write 1 times 360, and then I'm going to stop just for a moment and think about which side the negatives are on. Well, again, I'm trying to add to get a negative 31. So that means the bigger number has to be negative. So now I could keep going like this, but I can also sort of see that I'm really far apart. These numbers are really far apart. So if you want to, you can skip a little bit down the list and start a little bit further down, because you know you need to be a little bit more in the middle of the factors because the sum is negative 31. So I'm going to skip not very far. I'm just going to go to 5. So I'm going to skip 3 and 4 and go to 5. And again, if you can't do the division kind of by looking at it, then just do it over to the side. 5 goes into 36 7 times, and that'll give me 35, and then I'll have 10 left, so that's 72. That's still pretty far apart. 6 is easy to see that it's 6 times negative 60, though. Still too far apart. Let's skip a little bit. Let's go to 10. 10 times negative 36. 10 plus negative 36 is negative 26. So, oh, actually, I went too far. So let me take that one off. We can try 7. 7 is not going to divide into 360. Let's try 8. So 360 divided by 8. 8 goes into 36 4 times. That's 32. That's 40. That's 45. So times negative 45. That's closer, but not there yet. So let's try 9. 9 times negative 40. Oh, and there we go. There's negative 31. So you can skip around a little bit, but don't just randomly skip. Still try to go in some sort of order. Otherwise, you're probably going to miss the one that you needed. Okay? All right, so here we are again, making our two sets of factors. So again, I've got one that has more than one option. So 8b squared could be 8 times 1 or 4 times 2. But if I do 4 times 2, neither 4 or 2 will go into 9, so it can't be that. So it must be 8b and b. And then my outside product is one of these numbers. Well, I've got an 8, so it's going to be 8 times negative 5 to make the negative 40. And then there's a 1 here, so 1 times 9 to get my other factor for my inside. You can certainly, again, you should FOIL them so you can see how all of that connection works. So hopefully this will help between reviewing in class and then reviewing this. This should give you a really good basis on factoring, which we use a lot. So be sure that you know how to do factoring and ask questions in class, of course, as always, if you have any other questions about what to do.